Good morning. Okay, let's continue. So, in the previous two classes, we talked about descriptive statistics. So, we said that there are different kinds of descriptive statistics. Um, there are specifically those descriptive statistics that will describe what we call the central tendency, right? The central tendency of the distribution of data, right? Of data distribution. Data distribution. Okay? So we said that there are different kinds of central tendency in turn, right? So we have mode. Mode, as we said, is the value or values, right? There could be multiple modes. There could be the modes refer to the values that you know um, occur the most frequently in a sample, right? So for example, in this distribution, right, this is a histogram, right? And we know that histograms are graphic descriptions of the distribution of data, right? So imagine this sample, we have this distribution, and if we, sort of assume that these two bins are of the same height, then that means, right, because y-axis is the frequency, right, and x-axis value, and that means these two particular values occur equally frequently and more frequently than other values in this particular sample. So these two values are the modes, right, of the sample. And then we have median, right? Median, as we said, is the value, and there could only be one median, right? So um, median, really does not care the shape of the distribution. It could be skewed in any particular way. Of course, it can be a bell-shaped curve, which is perfectly symmetrical, or it can be any kind of skewed distribution, right? It doesn't matter. As long as, if we sort of imagine that this is where the data is, right? Here's the first person, and here's the last person, right? The nth person, right? The last person. So as long as this is the first, this is the last, so the median will always be the value that exactly divides the sample into two halves, so that 50% of the values will be below this person or this individual, and another 50% will be above this person. Okay, so median will always be at the center. And then with mean, right? Mean is mean essentially is the expected value, right? That is, if we have a large amount of data, right? If we have a large amount of data, and of course a large amount of values, then we ask ourselves, is there any one single value that I can expect from all these values, right? So in a distribution, there could be any kind of values in the sample, but in most cases, there is a tendency for the values to be sort of be best summarized, right, by one particular value, and then one particular value is the expected value. And we often call this expected value the mean, right? What we expect the value to be. So that would be the mean. That's sort of the conceptual definition of mean. Okay? And we know that mean is divided by summing up, right, all the values, all the x's, right, and then divided by the sample size. And then we also talk about what if, we know that there are two groups, right? Group 1 or multiple groups, right? Group 1, group 2, and even group 3, right? So let's clear that out. So, we talked about weighted mean, right? Weighted mean is very useful. Weighted mean. Weighted mean is very useful when we have information about subgroups, right? Imagine we have 3 subgroups and they are, their sample size are different, right? So N1, N2, and N3 are different from each other. So N1 does not equal N2, does not equal N3. Okay? And what we also know is the mean of these 3 groups, right? With M1, with M2, and we have M3. Okay? And now, if I ask you, okay, so given all these pieces of information, what is the overall mean, right, across all these 3 groups, that is, of the entire sample? Okay? So what is the overall mean? The wrong method, as we said yesterday, is to simply add up the 3 group means, right, and then divide it by 3. That would be wrong. And it will be wrong when the sample sizes of the 3 groups are different. Okay? So we cannot do it that way. So the correct way to do is, first of all, to find out the grand total of group 1. So the average times the sample size will give you the grand total. For group 1, we repeat that for group 2 and group 3. Okay? And then we divide it by the sample size of the entire sample. N1, N2, and 3, we sum them up. So that will give us the overall mean, right? The mean of the entire sample. So as you see, this is easily an expansion of the equation that we saw yesterday for the weighted mean for 2 groups, right? We can easily add, expand it to a situation that has 4 groups, 5 groups, all the way to, however many subgroups you will like, right? So essentially it will be to find out the grand totals for each group, and then you sum the grand total for each group together. That will give you the grand total for the entire sample, and then you divide the grand total for the entire sample by the total sample size. That will give you the correct mean of the sample. Okay? All right, so mean obviously then is a very important descriptive statistic that we use to describe a particular type of central tendency of the distribution of a sample data or population data. Okay? But now my question is, so, imagine that there are 2, let's say, or 3, okay? So let's imagine there are 3 distributions, and the shape of them are unknown. So we don't know how exactly they look like. But what you do know is that the mean of these 3 distributions, right? So that is, we collected 3 samples of data, right? But how exactly the values in these 3 samples are distributed, we don't know. But we do know that if we calculate the means of these 3 samples, we find them, these, M1, M2, and M3, to be identical. So, based on this piece of information, can we say that the distributions for these 3 sample of values will be the same? That is, can we say that these 3 samples of values are distributed identically because their means are identical? So can we say equal means, identical means? Let's put it that way. Identical means identical distribution. Can we say that identical means will give us identical distributions? Yes? No? Maybe? What's your answer? Okay. 3 sample values. We don't know how exactly the values are distributed, but we do know that if we calculate their means identical. So does that mean that whatever the shape is, they will have the same shape or the same kind of distribution? Okay, let's find out together. So, let's be more concrete. Imagine that we start with this very beautifully shaped distribution, right? We know that this is bell curved. It's symmetrical, right? Most of the values are clustered around the center with fewer values at the extremes. And of course, we know that as long as we impose the center line, so this is not exactly center, but let's assume it is the center. If we impose a center line, then this, right, this point here, intersection here, will be exactly the mean of this distribution, right? This is the mean. Now, we can impose sort of on this center line another distribution. Because distribution is also bell curved, bell shaped, perfectly symmetrical, it will have the same mean as this distribution. We can have yet another distribution, which is also symmetrical, bell shaped, whose mean is also here. So here we have 3 distributions that have identical means. But let me ask you, are these 3 distributions identical to each other? The answer is no. Okay, obviously they look very different from each other, other than the fact that they're all symmetrical and bell curved, bell shaped. But they do look very differently across each other, despite that they have the same mean. So how are they different? Well, very intuitively we say it looks like this distribution is narrower than this one, and this distribution is the widest, right? It's more spread out, in other words. And this is very clustered around each other. All the values looks like they're very narrowly dispersed. This is very widely dispersed, and this is sort of at the middle. And you're perfectly right, right? So as we said, the second very important type of descriptive statistic is what we call dispersion statistics. Dispersion statistics will exactly describe how spread out the distribution is. It's very narrowly clustered around the center, whereas the values are relatively far away from each other. Okay, so we say that this distribution, amount of 3, is one that with small dispersion, and this one in this among these 3 distributions has the largest dispersion. Okay. So dispersion, again, like central tendency, right, is a class of statistics that will describe how spread out a distribution is. Okay, and then also like central tendency, we have at least three specific dispersion statistics. We'll call them range, variance, and standard deviation. So range, the first type of dispersion statistic is very easily and intuitively defined It simply is the difference between the maximum value in a sample and the minimum value in the sample. In other words, mathematically, is the difference. You use the min. You subtract the minimum value from the maximum value. That will give you the range. Okay, and then if this difference is very large, that indicates that the sample distribution is very dispersed. If this difference is very small, right? What would be the smallest possible value? 0. It can be negative because it will always be the maximum value, the larger value, minus the smaller value, right? Of course, they could be the same, but you cannot reverse this equation, right? So the smallest is 0. That means there's no difference across a sample values. Well, how is that possible? Well, it is of course possible, right? So imagine that, on a 7-point scale, how much do you like, I don't know, how much do you like war? No one likes war. So you say everybody will give you a 1 on this particular scale. And if everybody gives you scores 1, then there's no difference, right, across the sample of people. Then, of course, the range is 0. There's no range. Well, there's 0 range, right? There's no difference, right? Or there's no dispersion within the sample. Okay? All right, so let's see if we really do get this. If now we have a sample value, 1 minus 3, 0 minus 2, 3, 2 minus 1. Okay? So this is the sample value. Now, what is the range? Find the range for this particular sample values. It will be, right, very easily, we should find first of all the maximum, the largest value in the sample. So what is the largest value in the sample? This one, right? So what is the smallest value? It's not 0 because we do have negative numbers, right? So it'll be this one. So the range is the largest value minus the smallest value. With 2 negative sign, that gives us a positive sign. So 6, right? So 6 is the range. There we go. Okay? Easy, huh? That's our first dispersion statistic. Okay. Now the second dispersion statistic is called variance. In our case, we'll talk about sample variance. Variance can also be used to describe populations. But in most cases, population variance is calculated slightly differently from sample variance. And because we will be dealing with sample variance most of the time, so we'll talk about sample variance. But just know that variance and all descriptive statistics can be used to describe populations, just as they can be used to describe samples. Okay, so warning. The definition of sample variance, the conceptual definition of sample variance, can be very complicated. Will be quite mouthful. Okay, so I will anyway give you the definition first, but just don't panic, and we'll walk through that definition together, and you will know how to calculate sample variance. Okay, so here we go. So sample variance is the adjusted mean. Is the adjusted mean squared the difference between each sample value relative to the sample mean. Okay, sample variance is the adjusted mean squared difference between each sample value relative to the sample mean. Okay, told you, it's quite a mouthful. But, if we dissect this definition, it will not be that difficult to understand, especially when we have a concrete example, right, with concrete numbers. So let's start with a very simple example. That is when we have three values here: -1, 0, and 1. Well, first of all, let me ask you, what is the range of the sample value, right? Obviously, it will be 1 minus -1. That will give you 2. So the range of this sample will be 2. Okay, so now let's find its variance. So the first step of finding sample variance is to find the mean, because sample mean is indeed a component of its definition. So we need to find sample mean. Okay, so sample mean. So what is the sample mean? Mean of these three values. Should be easy, right? So should be -1 plus 0 plus 1 divided by 3. Okay, that will give you 0. The mean of these three values is 0. Okay, now the second step is to find the difference between each sample value relative to the sample mean, right? The difference between each sample value relative to the sample mean. So we have three sample values. So what is the difference between this sample value and the mean? It will be 0, 1 minus 0. That will be 0, 1. What is the difference between this sample value relative to the sample mean? The mean 0 minus 0 is 0. What is the difference between this particular sample value and sample mean? It'll be 1. Okay, 1 minus 0, that's 1. Okay, so second step done. Third step, okay, is to square each difference. So it's the squared difference. See? The squared difference. So now we will square each of the differential squares. Okay? Should be easy, right? So what's the square of -1? It's 1. What's the square of 0? 0. What's the square of 1? 1. There we go. Now, okay, so there we go, right? So why do we have a negative sign here? So scratch that. We shouldn't have anything here. Okay. Oh, it's the dash. All right. Anyways, but just so you know, right, there should not be any negative sign, in front of it. Okay. The last step is to find the adjusted mean of the squared differences. Okay. So let's first just ignore this word adjusted. We'll soon find out what it means, but for now, just block this word, mentally block this word. If I ask you, well, how to find the mean of the squared differences, what would you do? If I ask you, hey, find the mean of these three values, find the average of these three values, what would you do? You sum them up and you count how many values are there. So there are 3. So you divide the sum by the number of values. There we go. That's the mean of these 3 values, right? That's what we talked about yesterday. So here, what's the mean of the squared differences? Well, where are the squared differences? These are the squared differences. See, this is a squared difference, the difference between -1 and 0. This is also a squared difference, the difference between 0 and 0. Here is a third squared difference between 1 and 0. So, simply you will find the mean of the squared difference. So, you sum them up. All right. And then you divide it by 3 because there are 3 of them, 3 squared differences. Okay? But then, okay, so now we have the mean of the squared differences. But what about this adjusted? Okay, so adjusted here, we'll adjust, what we are going to adjust is the denominator. It turns out that we'll always subtract 1 from the sample size. So sample size here is 3. So we will adjust the denominator by subtracting 1 from the sample size. That will be 3 minus 1. Okay? So here is the adjusted mean of the squared differences. And this will give us the sample variance. So what is it? Let's finish the calculation. So we know that this is 1, right? Minus 1, negative 1 minus 0, that's 1. Negative 1 squared is 1. Here is 0. And here is 1, right? Divided by 3 minus 1, that's 2. So here's 2, right? 1 plus 1, 2. 2 divided by 2 is 1. There we go. That's your sample variance. The sample variance of these 3 scores is 1. Easy, huh? Not that different. Okay, so now we know how to dissect this sentence, right? So the adjusted mean squared difference between each sample value relative to sample mean. So here is our first, right? It's the difference. We should first of all find the difference between each sample value relative to the sample mean. So of course, then the first step is actually to find the sample mean, and then we find the difference between each sample value, right? There's one sample value, second sample value, a third sample value. So we'll find the difference between each sample value relative to the mean, second value, the difference between second value and the mean, the third difference between, the difference between the third value and the mean, right? And then we'll square the differences, right? We have 3 differences, 1 difference, 2 differences, 3 differences. We squared these 3 differences, and then we find their mean. But it's not just any mean, it will be an adjusted mean. So it will always be n minus 1. Okay? So that's the definition of sample variance. So mathematically then, sample variance equals to this, right? So see, here's the sample mean. We find the difference between each sample value relative to the mean, each sample value relative to the mean, the difference between the last value and the mean. We square them up. We square each difference. We square each differential score, and then we find its adjusted mean. So that will be dividing the sum of these squared differences by sample size less 1. Okay? So as a shorthand of this long expression will be, remember this is the summation sign, right? That means we'll sum all the square difference between any sample value relative to the mean. Okay? And then we divide the sum by sample size minus 1. Well, you may ask, why do we want to subtract 1 from the sample size? Well, the answer will be for a more advanced class in statistics. So that means we'll not go through the reason here, but just keep in mind that we'll always divide the summation by n minus 1. Okay. All right. So again, larger values, right? Larger variances indicate higher levels of dispersion within the sample. Okay. How about as an exercise, you find the variance for this particular sample value. How about that? you know, you should pause now and work it out by yourself. Okay, so you should pause. But then, I will write out the expression so that you know whether or not you got it right. Okay. All right. So again, our first step is to find out what's the mean. Okay, what's the mean of these 7 values? 3, 3, 1. So 7 values. So again, I make your job easy. So if you're sort of familiar with calculating these kind of values, you know that 1 cancels out with -1, 2 cancel this out with -2, and these two will also cancel each other out. So the mean actually is 0. Okay. The second step, as we said, is find the difference between each sample value relative to the mean, right? So you will be -3 minus 0, -2 minus 0, -1 minus 0, 0 minus 0, 1 minus 0, 2 minus 0, and 3 minus 0. Okay? Next step is to square all the differential scores. Square them up. Square the differential scores. Square the differential scores. You square the differential scores. You square the differential scores. You square the differential scores. There we go. Okay? And then you find the adjusted mean of all these squared differences. So how do we do that? We, of course, whenever we're finding mean, right, we should always get a summation, the grand total of the sample value. So we sum them up. And then we should divide by n minus 1. So what's n here? We have 1 squared difference, 2, 3, 4, 5, 6, 7. We have 7 squared differences here. So n is 7, but it's adjusted mean, so it will be 7 minus 1. Okay? So now it should be very easy, right? It will be, this will be 6, right? So here is 9 plus 4, right, plus 1. And then there will be a second set of 9 plus 4, 9 plus 1, because here's 1, 4, 9. Okay, so just times 2 here. But then 2, if we divide 6 by 2, we'll be left with 3 here. And then here is 9 plus 4, that's 13. 13 plus 1, that's 14. So it will be 14 over 3. It will be 4.7, maybe. About 4.7. Okay. Or 4.6, I don't know, 9, something like that. Okay. Let's see if that's the case. So 14 divided by 3. Okay, so it's 4.67, not 4.69. All right, close enough. So this will be the answer. This will be the variance of these sample scores. Did you get it? Okay. Now the last dispersion statistic will be sample standard deviation, or SD. The calculation of sample standard deviation will be very easy. That's the square root of the sample variance. So whenever you want to find the sample standard deviation, you always need to find out the sample variance. And then once you find out the sample variance, you take the square root of it. Okay, so here's the sample variance, the thing that we just talked about. And then to find sample standard deviation, you just find it, take the square root of the sample variance, and you have the sample SD. We need sample SD because you see here, right, for sample variance, it's based on squared, sum of squares. And whenever you square something, that sort of will make the values very large, and it's very difficult to interpret. So one way to reduce this variance back to the original metric is to, take the square root, because we squared here, so we'll take the square root. Okay, so that will make the variance easier to interpret. Okay, so that you have the same metric as other descriptive statistics, mean, range, etc. Okay, both sample variance and standard deviation are very important, which we'll see in our future classes, right, after our second examination. But for now, your job is to understand how to calculate all three kinds of dispersion statistics, right? I'll provide, of course, all the formula in the exam, so you don't have to memorize the formula, but you do need to know how to plug in the numbers, okay? And of course, to know how it works, okay? So this class is short, but I want to make sure that, I would like you to make sure that you know how to calculate all these, dispersion statistics. There will be our third homework due by the end of today. It's not very difficult. It's all, based on, it's all about how do we calculate central tendency statistics and dispersion statistics, right? So the plan, at least I see it, is you will finish this homework by tonight, submit it through Laulima, and then you will bring it to the Q&A session, review session tomorrow on Thursday, right? So that we can go through all the questions together, lest you need some reassurance or help with questions, right? So that way, we can kill two birds with one stone, right? With one session, we solve your problem, we walk through the problem set, and then we sort of review what needs to be known for the examination. Okay, so anyway, so I will see you, hopefully most of you, tomorrow at 10:30 at room George Hall 213 for our review session, and our second examination will be at 10:30 on Friday, this Friday, in George 213 as well. So after exam, you can all go and watch Jason Bourne, which I very much look forward to. Okay, I will see you in the Q&A session and in an exam.